fractions, subtraction, subtracting fractions. So just like in addition, first we're going to have to make sure the fractions have the same denominator before subtracting. And if they're not the same, then we will have to get the fractions to have the same denominator. And once they have the same denominator, then we can subtract the numerators together, and then we're going to keep the denominator. And then lastly, we will reduce the fraction to lowest terms if possible. So let's do some examples. So example 1, subtract the following. We have 4/7 minus 1/7. So we're going to see that we do have a common denominator. So this one is a little bit more straightforward. So how we do this is we just go ahead and subtract the numerators. So 4 minus 1, which is 3, and then we keep our denominator, which is 7. So it's really important that we always keep the denominator and then we only do the subtraction on the numerators. Now let's do another example. So let's look at the prime factorization of our denominators because we see that they're different. So we have 3, which is just 3. So this is a prime number. So we don't actually have to do any prime factorization on this one. Now, let's look at 6. How can we break this down? Well, this can be broken down into 2 and 3. So the prime numbers of 6 broken down for is just 2 and 3 multiplied together. So here's the trick. So we notice this 6 has a 2 and a 3. And then we notice this one just has a 3. So what is the 3 missing? It's just missing a factor of 2, or the prime number 2 that's being multiplied. So when we rewrite our fraction, so 1/3, if we're missing a 2, we just need to go ahead and multiply them. So whatever we multiply, we're going to have to do it on the top and the bottom on the fraction because we're just wanting to change the number but not the value of the fraction. So this is just multiplying it by 1, essentially, because 2 over 2 is just equal to 1. Then we have minus 1 over 6, which is just 2 times 3, right? So now we can see that we have this all multiplied out. So when we go back, we're going to go ahead and multiply the top numbers together. We multiply the bottom numbers together. So this 1 times 2, which is 2. 3 times 2, which is 6. Minus 1 over 6, because that's just what it was already. So now we have it set up to have a common denominator. So we have 2 6 minus 1 6, which is equal to 1 over 6. And that would be our solution. So we use prime factorization here to find the missing factors. So this one was broken down into 2 and 3. So we just need to multiply it by the missing one, which was 2, which we did here. We multiplied that whole fraction with another fraction of 2 over 2 to get the same common denominator. So let's do this again in the next example using prime factorization as our trick. Example 3, subtract the following. 2 6 minus 1/8. So for this, we're going to use prime factorization. Because in the last example, in the last video, we did it by finding the least common multiple that's shared between the two denominators. This time we're going to use prime factorization to get to a common denominator. Both work, but we're going to use it this way to see how this works. a little bit more clearly. So use prime factorization to find a common denominator. So we have 6 and 8. They're not the same, so we need to find the prime factorization of each one. So 6 can be broken down into, well, 6 is even, so it could be 2 and then 3. So those are both prime numbers. So we're going to circle them to show that we're done. Then we're going to look at 8. 8 can be broken down into, well, 8's even too, so that's 2, and then 4, and then 4 is even. It can be broken down into 2 and 2. So now we're done finding the prime factorization of both numbers. Then what we do is we look at both numbers and see if we share any numbers that are the same for prime numbers. So we're going to notice we share a 2 and this 2. And then we also then don't share this 3 between them. And then this 8 has an additional 2. So when we look to make our common denominator, we're going to have to use all these numbers. So we're only going to take this 1, 2 that's shared between both of them. So our common denominator is going to be 2. So from this 2, then we have additional 2 that we need to consider. And then we have this 3. So let's recap. So we share a common prime number that's between these two, which is both each have 1, 2. But 8 has an additional 2, so that's why we counted for the 3. But the 6 has this 2, and then it has this 3. So we have accounted for all the prime numbers that make up the different denominators. And now when we multiply all that together, this will be our denominator. So 2 times 2, which is 4, times another 2 is 8, which is right here, which is what we did. Now 8 times 3, which is 24. So this is our common denominator. Now let's go ahead and rewrite this problem. So we have 2, 6. Well, instead of writing 6, we're going to write it as 2 times 3. And we're just going to enclose this with parentheses. Well, now we need to multiply it by the missing factors, or like prime numbers, which are going to be these 2 2's, right? So it's missing 2 times 2, because you want to have these 4 numbers now to make up to 24. Now, whatever we do to the bottom, we have to do to the top, because we just want to change the numbers, not the value. So now we have that, the first fraction set up. Then we have minus 1/8. Well, 8 can be broken down into 2 times 2 times 2. So what's the number that it's missing? Well, it's only missing this 3 because it has this first 3 2's. So if we just go 3 over 3, then we are set up. So let's go ahead and now multiply everything that's on the top. This 1 times this 3. And then we will multiply all these bottom numbers, which we already know goes up to 24. So now let's go back. So this 2 times 2 times 2, well, 3 2's being multiplied together is equal to 8, which is, this is over 24, minus 1 times 3, which is 3, over 24. Now we have a common denominator, and now we can go ahead and subtract. So we just subtract, right, the top numbers, and we're going to keep the denominator. So 8 minus 3 is equal to 5. And then this is over 24. And this is our final solution. 5 over 24, because we can't reduce this any further because 5 is a prime number and 24, and 24 doesn't have a factor or a 5 in it. So we are done.